Hey everyone, we're Team 3, the Autonomous Library Project. I'm Nate Largo. I was in charge of the pathfinding and the grabber actuation.
Oh, I'm Zack Rankin, and I was in charge of the motor control and also trying to determining points to complete the map.
My name is Puneet Yadav. I was responsible for mapping algorithm for the project.
All right, now we're cooking with fire. So in our project, the Autonomous Library, we have an arena that's about 100 centimeters by 100 centimeters, and 2 rovers that will be maneuvering through this arena. In the arena, there is a certain number of boxes. They're little boxes. Actually, you know what? Boxes, right? So these boxes, they sit right here in the map somewhere, and it is the inventory rover, the purple rover in this diagram, the inventory rover's job to move around and find all of the boxes. It doesn't know where they are at the start, but it will find them. Once it finds them, it goes out to the inventory rover exit up here, and it sits there and does nothing for the rest of the whole entire execution. The retrieval rover then moves into action, moves into the arena, and waits for a user or someone outside of the situation to request a book. They request a book, let's say this book for example, and the retrieval rover will move into action. It'll move right up to that book, pick it up, or grab it, and then move it to the drop-off point where it can be released. And that's basically the whole project.
Alright, so when it comes to the inventory rover, the first thing that's going to do is it's going to try and travel around the perimeter of the arena. So by traveling around the perimeter of the arena, we get most of the mapping data we're going to need. So the first thing it's going to do is it's going to make a path request to the pathfinding pick, and it's just going to say, I want to get to this point. Because this is the first goal, and we have this safe zone around the whole area that we know for sure the rover can travel around it. So we want to go ahead and take advantage of that. So the first thing it's going to do is come up here. The pathfinding pick is basically going to tell it, here's how you get to this point, and then it's going to directly go to that point. And then it's going to give it another point. So it's going to give it this point right here. It's going to travel to that point. It's going to make another request, travel down to this point, and it's going to make another path request, and it's going to travel over to this point. And now, the next step is it's going to basically run through the entire map. So this whole entire time, I'm constantly pulling the map down. So there's a bunch of points and that has like confidence levels, and so based off of that, I need to make a determination of is the map complete or not. So if the map's complete, that means we're wholly confident about the entire map. We know everywhere there's an object, we know where there's empty space, and basically there's no more information to collect. We're going to be good to retrieve. But in the situation that the map isn't complete, you need to go fill in those points. And so the whole goal now is I look through the whole map and I try and find like empty spots in the map that you would want to fill in. So obviously, like in the middle right here, there's going to be a point that in no way, shape, or form is there going to be data. And so constantly as it's going around, you can see that they have the ultrasonic sensors are on the side, front, and then the other side. And so these are the ones that are giving the mapping pick information to actually be able to decide where there is an object. And so as it's going around the perimeter, you're never going to get an ultrasonic that tells you, what's going on inside these 4 boxes. And this is one of the situations where, every single time you're never going to have data about it. And so what I'd want to do, I'd be like, okay, so I have this point right here, and maybe I have like a couple other points. There's probably a bunch of grid spaces right here that are all not filled in. And so what I would do is I would look through the entire map and say, I find a spot, and I want to find the spot with the most unknown grid spaces. So in this situation, this would be a huge part that I wouldn't know. And so say I would try and travel to a spot where, say we're confident about this entire area around it. So this red space, we're fully confident that this is, empty, or we know it's empty. And so it's safe to travel. So it'll pick a point around here basically where I can move to where the ultrasonic sensor will end up hitting that area so we can fill in the map. And so now I'll make a path request to get there. The pathfinding pick will tell me, okay, if you want to get there, you're going to move over to here. You're going to move up, maybe move to the side, and then you're going to move, say, inside the center. So at this point, now the rover's sitting inside. The ultrasonic sensors are now picking up data for this, center area. There could be a box there. There could not be a box there. But either way, we find out what's going on in the center of it. And then, granted that, we have the entire map filled in now, we would want to exit, and so once again make a path request to the pathfinding pick. And so now I want to get up to here. So I would go in, move out, come up, and sit here, and then I'll exit. And when I exit, I basically send up a message, and the message to the server says, okay, retrieval rover, you're good to move in. The retrieval rover is going to move in. And then also the mapping pick that is taking all the ultrasonic data as I go around is going to calculate the centroids of all the points that is basically in this like confidence map. So for things like this box, you're going to have a bunch of points all around it that all have a high confidence, and it's going to calculate the point. And then we have added to the server. Now we know there's book 1 right here, book 2, book 3, and book 4.
My name is Puneet. I was responsible for the mapping algorithm for our inventory rover. So the mapping algorithm works in a way that it takes the data from the ultrasonic sensors and the encoder ticks. Encoder ticks are basically calculating how much the wheel has moved every 250 milliseconds. I used all the data from the ultrasonic and encoder data to estimate the position of these books. So once I estimated the position of these books, I increased or decreased the confidence level. So once I found the book, I increased the confidence level using the data from ultrasonic sensor, and the encoder tick was used to find the exact position the rover was moving at. Once I found all these small dots or small XY coordinates with different confidence level, I used a k-means cluster algorithm to create clusters and find the centroids of those blocks, which could be used by the retrieval rover to pick it up and drop it off.
So this is the retrieval rover. It's got a bunch of machinery on there, but it's got this little actuator on the front, which will come down around a box. You can see it's kind of like a little ring. Comes down around a box when it's time to actually grab the box. Basically like this, just whoop, kind of can't really actuate it, but comes down around the box and then pushes the box around. Really high-tech stuff here. So when the retrieval rover starts its lifetime, the inventory rover will have just moved out of the arena, and it comes in right to here. Comes out to about here. And it kind of sits there and downloads the whole map from the inventory rover, because the inventory rover is done at this point. It knows the whole map. So the retrieval rover comes out, stops here, gets the whole map, and then it waits. It just waits until the user requests a book. So in this case, let's say we have this book in the middle is literally book 1, right? So we have book 1 in the center of the arena, and the user requests book 1. The retrieval rover will attempt to move to a location close enough to this book to actually grab it with the actuator. So it comes out, and because of the way its pathfinding works, it really tries to avoid that box, but it decides that this is the best point to pick it up, because then it can drop it off right afterward. So what it's going to end up doing is it'll come down, it'll come over, and then it'll come back up. And all this time it's staying far enough away from the wall so that it doesn't bump into the wall, and it's staying far enough away from the box that it's not going to bump into the box. Once it gets here, it actuates, grabs the book, and then it turns around and will come straight down into the drop-off point where it will release the book, and the book will now be in the drop-off point. Once it's dropped the book into the drop-off point, it'll just sit there and wait for the user to request another book. Once that happens, it spins back up into action, getting that other book.
All right, so what's happening right now is the rover is moving forward to the very first location to basically start getting the map as a whole. So the mapping pick would be off to the side, and so it's constantly receiving the ultrasonic data from the 3 ultrasonics. There's one in the front, there's one on the left, and there's one on the right. You can see the little eyes peeking out. And so we're just going around the map trying to collect as much data as we can.
And it's good to note that right now that pick on that rover is communicating with the rover that's kind of at the bottom of the screen, sitting, doing nothing. The the retrieval rover, which is sitting down there, is currently giving very basic directions to Zack's rover, because Zack's rover the mapping rover is just asking for points that are basically in a straight line, but it is communicating with the retrieval rover to actually ensure that there's nothing in the way, which there never should be because we have
created a safe zone.
Yeah.
And so once it gets to the end right here, so this is going to be the last point where it's like we know that we're done moving in like the safe area. So if any other points we need to move to, we're probably going to move inside. And you might be able to see the
It was really fast.
The other rover starts to twitch when it is pulling down the map through no fault of our own.
Yeah.
And so, as you can see, it starts drifting off to the right, and it's going to hit the wall here. And so this is partly due to the fact that our motors are being controlled by
just pure PWM, just pulse width modulation, setting a voltage basically to be an analog, a pseudo-analog value. Normally what you'd want to do is actually have a system in place that will correct. If one motor starts to move faster than the other, it would correct and then kind of fix it so that they do move at the same rate. We didn't end up getting that implemented, so we're just running off of straight hard-coded values basically that we tweaked to make look right. The downside, though, is that as the battery starts to drain, those numbers aren't really right anymore, so the rover can start to move inaccurately.
And one problem, too, is as the treads get dirtier, that's one thing that the algorithm Nate was talking about is PID. And so, basically, even as the treads get dirtier, there's nothing you can really do about making sure the treads are moving at the same rate because, they're going to start to slip a little bit.
Mm-hmm.
And that's why you kind of need another component implemented to account for like orientation or making sure that you've gone the right amount of distance as opposed to just assuming that everything happened correctly.
Right. So now the mapping rover has finished its job. The retrieval rover is going to move into its starting position, and here you can see if you look closely, you can see the actuator is actually twitching a little. That indicates that it's downloading the map. So it's downloading the map from the mapping rover, the one that was created, and it's going to use that to actually maneuver through the map when someone requests a book. So you can see someone requested a book, it's going to start moving. So it's going to sort of move towards the box, then it's going to turn around and move a little bit further away from the box just to come at it from a nice vantage point. And then once it moves into position, it will end up grabbing the book. So it's going to make a couple more turns here.
And one thing about the second pick that's mounted on top of the pick that's taking the book request is the only thing it's really doing is it's sitting there constantly taking destination. So the book request gets sent in, so we're going to retrieve book 1, and so we know that after calculating the centroids, so the book after the map's created, we can calculate the center point of it, and so now we know where the book's at, and we can go ahead and just go and grab it.
Yep.
And so now it's going to say, okay, I want to take it to the endpoint,
which is directly beneath it right now. And so it's just going to pull a 180 and then move that box into position. And then once the box is actually there, it'll lift up its actuator, and it will then wait there until another book request comes in.
And so in this case, it won't keep running forever. It'll run until basically you've pulled all the boxes. I guess the reliability is kind of falls short because of the fact that the battery life alone can affect the rover's movement. At 80% battery life, you can see we only had to adjust it once, but we tested it again with 50% battery life, and completely changes the way the rover reacts.
Yeah.
One thing I wanted to add about the sensors is that even though the sensor is, shooting, so it's constantly shooting out ultrasonic waves, and it's determining how long it takes for those waves to come back and be received after bouncing off an object. And now, when it comes to the mapping too, even though the ultrasonic sensors are pulsating out and hitting the object, it has a certain radius. Basically like an arc length at the end of like around 20 degrees that it's shooting out. And so even if it's not directly on an object, it's likely that the farther the object is away, it's still going to count it as a hit.